So, just to wrap things up, I will do here at the very end of the course what I usually do at the very beginning of my lectures that I give at scientific conferences all over the world, and also for other people, general public, sometimes for politicians in Almedalen or Swedish Parliament. I usually have a slide that I almost always start with. And for those of you who have taken the course physically, you know, you might have seen this. And for those of you who heard me give a lecture, you've probably seen this as well. But I want to do it here at the end because it somehow, hopefully, will give you a feeling that all of the things I'm talking about in this first slide, you now know much more of what actually goes on in terms of all of the methods and the concepts and ideas and so on. So the first thing I say is that I want to talk to you about a new way of doing healthcare, a new model for health, M for health. But M for health also stands for the type of models that I do, which are mechanistic models, which are multi-level from whole body down to the intracellular level, multi-timescale and multi-organ. And we create these models by combining prior knowledge about what happens in the system with all sorts of different type of data, images and time series and continuous glucose monitoring, which allows us to continuously update models and basically incorporate all that we know, both in terms of knowledge and in terms of data, into a digital twin. And this digital twin describes what happens in the different organs in the body, and we build it up in a modular way where we combine these different sub-models as modules into an interconnected model for the body as a whole. And we want this to be useful for the entire healthcare journey, from you being essentially healthy and doing normal everyday stuff, maybe getting some sensor that can allow you to know what's going on into your body, until you eventually at one day or another end up in healthcare, and then you want to do some rehabilitation maybe after your first treatment, and eventually you go into elder care. The idea is that you have your digital twin with you throughout your health journey. And for those of you who don't know it, the digital twin is a computer copy of something. So here we see a symbolic digital twin of a cedar tree. And the tree is interesting because it's sort of a decision, it's symbolic for a decision or an electric circuit here, or a computer circuit. And we want to inspire people to make sound medical decisions by developing and analyzing the models in a sound way and looking for the most sound possible things that the person can do. And because of that, the name of the spin-off company that converts this into a product is called Sund, which also happens to be the part of my last name. And this happens to be a cedar tree here, so it's which is the first part of my last name. I also run research groups, particularly in Linköping University, but also starting up one in Örebro University. And the logotype of my research group is here, and this symbolizes that we go beyond what you typically think about when you talk about AI, because our models, you can look inside, they are mechanistic. And you can also see which parts of the predictions, which aspects of the model that are well determined and which are not. And the well determined parts we call the core predictions. So that's symbolized by the core ball here in the middle. And nowadays we also do hybrid models where we combine our mechanistic model with machine learning models and other statistical models to be able to incorporate all type of data and all type of knowledge into an interconnected model. But here, for sort of aesthetic reasons, it's not included, but we do use a hybrid approach to create these digital twins. And this is basically all that we have gone through in the course, and it's you sort of now hopefully feel that you have the sort of understanding of the methods that are used to take all of these different steps, to use the data, to incorporate the knowledge, to find the predictions with uncertainty, to use things in a sound way, to make decisions that are based on a robust part of the model that has been validated, that are not too far away from the validation data, and so on. So all of these are things that you hopefully now have a feeling that you know how to do. And if you don't, it might be because you have forgotten things, and then you can of course go back to those videos. Or if you want to get a more hands-on understanding, you should do some of the computer exercises. And if you want to go even deeper, then you should contact us, because then maybe you want to do an internship or an in-depth part, which is also part of the course if you take the full course. But we are also very interested in master students, and that do the master's project, or that do an internship, or that spend some time with us. So if you are interested in going beyond what we do in this course and going to a full sort of project, then you should drop us an email. Okay, that was it for this video and for this course. Thank you for listening, and I hope it's been useful for you.